Hello and welcome to the Badger Talks podcast, the podcast that shares interviews with experts from the University of Wisconsin-Madison community about their work, research, and a little bit about what they're like as people, too. I'm your host, Buzz Kemper. Today, we'll be talking about the human brain, and I'm happy to have as my guest Dr. Jack Nitschke. He is a clinical psychologist, neuroscientist, and associate professor in the Department of Psychiatry at the University of Wisconsin-Madison. His 20 years of NIH-funded research used brain imaging to answer questions about anxiety, depression, and emotion. His brain-based model of anxiety was published in Nature Review's Neuroscience. Jack Nitschke, welcome to the program. It's great to have you in here. And so we're in the month of Halloween. And so I want to start with just, you've done so much research into, various aspects of the brain and how the brain works. And so when we feel an intense emotion, let's say fear, let's say we're terrified, is it a chemical, an electrical, or actual physical changes that happen? What is it that we know about that through your research?
Yeah, so the answer about chemical, physical, neural changes, the answer to that is yes.
All of the above?
All of the above. So there's a lot of changes going on in the brain when we get scared, and there's a lot of different brain regions that are involved when we get scared. It was 30 years ago that some research was being done on fear, mostly in animal models. So that means non-human models, like a rodent model. Mm-hmm. And a lot of that was really focused in on, a specific area of the brain. And that one is the amygdala. And so everybody thought that was the fear center of the brain. Well, we got into doing neuroimaging where we could, for the first time in human history, look into the brain, in real time. And we found out that that a number of brain regions were involved when people had the experience of fear.
How many regions does the brain have?
Oh, boy. It depends on how much you're going to break it down.
Oh, really?
It's a great number of regions. I mean, if you want to look very coarsely, it's got two hemispheres and a cerebellum. Right. If you want to divide it up a little bit more, you talk about different lobes of the brain, a frontal, temporal, parietal, occipital.
Okay.
But then we go much further than that. That's a very coarse division of the brain in that way. And so there we're looking at particular brain areas. And there we can have some larger brain areas such as the prefrontal cortex, which can be further subdivided into dorsolateral prefrontal cortex, dorsal medial prefrontal cortex. So a lot of big names, but they just essentially point out the different areas of the prefrontal cortex, which is a large amount of real estate in the front of our brains, and dividing that up into areas that are more ventral, which means lower down, areas that are more dorsal, areas that are more lateral, which means to the outside, and areas that are more medial, which means to the inside. And then underneath the cortex, so that's what these different lobes are, underneath all that are a number of what we call subcortical structures. And there are both cortical as well as subcortical structures that are involved in the experience of fear. So amygdala is one of those areas that is underneath the cortex. And it is comprised of multiple nuclei. It's actually not just a single structure, but has a lot of nuclei that are involved in it. And that's right next to the hippocampus, which became famous for its involvement in memory, critically important for learning, spatial navigation, but also involved in different types of emotional states. So that gets active when you have a fear state too. Another key area that's active is a very interesting area that got almost no attention at all 30 years ago, but has really blossomed in terms of the amount of attention it received since we started doing neuroimaging, because it kept lighting up, especially in studies of emotion. And that area is called the insular cortex, and it's kind of in between the parietal lobe and the frontal lobe up high, and down low the temporal lobe. So, and it's
insula cortex?
Insula cortex,
Okay.
or you could just call it the insula.
Okay.
And it appears to be involved in pain, but also moment-to-moment awareness, which is obviously going to have some salience for somebody who's experienced fear, which is something that's going on in that present moment.
Right. Okay, that makes sense. So when you say these are areas that light up, you use the term light up, I assume that means that you are monitoring. Explain that term.
It's a great question. Okay, yeah, light up doesn't mean that our brains just all of a sudden turn on a light as we are experiencing these emotions. Light up is what us neuroimagers have used to explain when the analysis that we're doing on the brain shows a particular area that is being involved. It just means that area is active. For me, I did fMRI research. It means there are changes in the composition of the blood in terms of the amount of hemoglobin or oxygen that's there. That's what we can measure. We actually measure oxygenated versus deoxygenated hemoglobin as a metric of whether that part of the brain was active. Okay, and that's yeah, and so that's what, when we say light up, then we have a certain color that we assign to a certain amount of change in that particular brain area.
Okay.
And that what shows us a nice pretty pictures that, you know, a number of times people have seen that says, oh wow, here's the insula that is active, or here's the amygdala that's active. What's going on in the brain? What's going on in the brain is that neurons are firing. It's that simple, okay? And that involves chemical changes in between neurons that fire, but also involves electrical activity. And that's another thing that can be measured and is measured both at the scalp, or you can put electrodes in the brain. It's a little more invasive, but you can measure the electrical activity of even individual neurons in the brain.
Wow. And you mentioned that we are giving birth to neurons all the time, like we are right now, because I'm trying to understand and process what you're telling me, and that is actually helping my brain. Let's get into that. How does that work?
Yeah, at the same time that I was spending the first part of my career, first 20 years of my career, from the early 90s until, 2015, focusing in on neuroimaging, there was another whole body of research that was going on a more molecular level that was looking at what's going on at the neuron level, which we're not looking at with neuroimaging. That's too small of a level to be able to image with our current tools. So, and what we discovered there is a number of things, very exciting things are happening in the brain. For one, there are these new neurons being born. When I was in college, we had in our psychology textbooks that you're born with about 10 billion brains. 10 billion neurons. You're born.
I could use 10 billion brains, but
we are born with about 10 billion neurons, which is pretty much right still, maybe a little bit more than that. And then slowly over life, that kind of gets whittled away, and they die off across lifetime. And good idea not to go boxing and not to play football, because that's going to increase the amount of cell death that happens for those neurons. And that's still a good idea not to do that.
Yeah, we've seen that in older boxers and football players, that there is damage there. Yeah,
right, and even younger, younger football players with CTE that we now know about. But at any rate, but what we now know is that there are these new neurons that are being born in our brain and other mammalian species as well. For humans, the primary area that these new neurons are born is actually in the area of the hippocampus. And that hippocampus is in our brains the seat of memory and learning. Okay. How convenient to have that designed to have most of the new neurons that are being born in the human brain to be in that area.
Okay, and this is the area I assume that is most profoundly affected with things like dementia.
Yeah, it depends on the type of dementia. It
Okay.
is eventually, but for Alzheimer's, yes, Alzheimer's is, pretty much strikes that what's called the medial temporal lobe, that area of the brain where the hippocampus lives, is affected first by Alzheimer's dementia.
Okay.
At any rate, you and I are, in the course of this conversation, giving birth to new neurons. A few new neurons are being born for each of us right now.
Terrific. I need as many as I can get.
Right on. There's 700 new neurons is the best estimate in each hippocampus. We have one on the right side of our brain and one on the left side of the brain.
Okay.
And every single day, there's 700 new neurons being born on average there. And it continues well into adulthood. How late it goes is still not totally known, but it's known to go at least into the 70s. And neuroplasticity, I can tell you, is alive and well beyond that. As long as you can keep learning, that means neuroplasticity is doing its job. What is neuroplasticity? It's comprised of...
I want to get into that because that's a word that could be taken so many ways. Let's dive into neuroplasticity.
Neuroplasticity is essentially the idea that there are functional and structural changes that are occurring in our brains that allow us to do things such as learn. Okay. And there are a number of different mechanisms involved in neuroplasticity. One of them is what I just talked about. The fancy word for that is neurogenesis. Just means the birth of new neurons. In addition, there is what's called dendritic spine growth. So it's like these neurons that are sending out different types of connections or spines, so there's this active growth going on all the time as our neurons are sprouting new dendrites to go out, and that helps to make connections with other neurons, which is called synaptogenesis. So again, that genesis is just the building of a new synapse. That's when two neurons make contact with each other for the first time. And then another part of neuroplasticity is what's called long-term potentiation, which we've known about for a long time, and that's just is a measure of the amount of strength that a neural connection has, and just how easy it becomes for that one neuron firing to lead to a second neuron that it's connected to fire, and that just starts to build up our neural connections and neural networks in our brains.
I have so many follow-ups. So let's start with this. You say when two neurons connect for the first time, what is the cause of that? Is it because we're learning something new, or we're thinking of something in a different way, or is it a random thing that happens? What causes this connection?
That's a very good question, and that level of detail we don't really know. What we do know is that there are tons of new neural connections being made every day, and what it may be is that these neural connections that are kind of almost happening in a haphazard way are just being linked up with different kinds of experiences that we're having throughout the day, and so there's a lot of things that are happening throughout our day. So even here, just sitting in the studio, there's this big black box over here on the side. I formed a neural connection that is kind of helping me to register that that's here, and there's other, there's a piano over on that side, which I'm not even looking at. So I know this stuff, but a lot of that stuff's not very important. And so what we know that happens, and this is some of the research that's going on here at the University of Wisconsin and in my Department of Psychiatry, and with Giulio Tononi and Chiara Cirelli, they're doing some of this work on sleep, is that a lot of these neural connections that we're making through the day, they actually get pruned during the night. Neural connections that are made as we go through the day that represent things that are just not that important, that gets pruned out. Neural connections that are made for learning something that's going to be on our exam tomorrow, or learning something that's going to be important for us to stay safe, we want to keep those neural connections. And so how does that happen, and what goes on? Like, how does the brain decide which connections to keep and which not to? The estimates are about 85% of new neural connections made during the day get pruned out. We keep 15%. Because we're constantly, again, making neural connections for a whole host of different things. A lot of information we don't really need. The idea is, like, if we just kept making neural connections, we just have so many gazillion neural connections that, our brain would just be like too much. And so this is a way to kind of to conserve and to really focus in on whatever's going to be really useful for us as an organism going forward.
And I've long been fascinated as to how the brain prioritizes that, because when I was a university student, I did a lot of theater. I had these terrific drama coaches, and we did all kinds of different plays, short stories, all kinds of things. 99% of that is gone, but there is one Shakespeare monologue from The Merchant of Venice that I can still do word for word. Why is that? I haven't prioritized that consciously. Is there any reason why my brain decided to retain that one nugget?
There's some things that may have contributed to it. Okay. So I'll talk about two of them. One is one of the most important things for whether or not something is maintained or not is the amount of repetition it gets.
Okay.
So basically, anything you want to learn well, it's what we know kind of as we walk through life. Anything you want to learn well, you just repeat it a bunch. You'll get better and better. Study, just lots of repetition, and your brain is going to be like, all right, this must be important. And it does all the neuroplasticity it needs to, using all those different mechanisms I just talked to build up neural connections that support holding on to that information. So one possibility is that even though you didn't realize it, you actually gave that Merchant of Venice got a heck of a lot more repetition than did other things. You either performed it a lot more, or you practiced it a lot more, or something helped you to do it a lot more. That may have happened. Okay. Another thing that can affect how well something is learned is the emotional valence that gets attached to it. And sometimes that could be something that's pretty negative and then becomes a little bit sticky through that, in part maybe because we're worried about it, we repeat it a lot. Or in your case with Merchant of Venice, where you really enjoy this, it might be some positive emotion. It's like, oh, this is really cool. I love how Shakespeare puts this and this together, and there's just this extra, emotion, positivity that gets linked in with it that just, affects the amount of neural firing that's going on for those associations, for memorizing and knowing that particular, those particular verses.
That makes sense. And I think that it probably was just a really meaningful experience for me because it was the first Shakespeare thing I had really done. When we talk about neuroplasticity, are there physical changes in the brain, or is it a change in the way that the electrical signal paths, the way the neurons are connecting, or, as with my first question, is it all of the above? What creates, or not creates, but how does neuroplasticity look to us if we're observing it?
If you're observing the brain?
Yeah, if you're observing the brain.
Yeah, you have to look at a very molecular level.
Okay.
And generally speaking, you could talk about neuroplasticity as on a larger level, and people indeed have done this. So looking at, you can use a certain MRI technique called diffusion tensor imaging, and you can actually look at the increase integrity of some connections, almost in essence, almost like how much connectivity there is. But getting big changes in white matter is pretty hard to do, but there are reports of it, right?
Okay.
The way I like to think about it is much more on a molecular level, and the way it looks is just some of those mechanisms I've talked to you about. The new neurons that have been born, as they mature a little bit, they get taken up into new sets of neural connections. At somewhere a week or 2 weeks in, they get pulled in. So neuroplasticity is going to look like, hey, these guys are now involved in this neural connections for reciting Merchant of Venice. Right?
Okay.
And in addition, what it looks like is that there's a bunch more neurons that are involved in this Merchant of Venice piece than were there the first day I did it. And then those neurons are much more likely to fire to signal one another. It's just really easy for the Merchant of Venice neural connections to do their thing.
Yeah, that is amazing. So in all this research that you've done, and I know that you have done a lot of groundbreaking work, what has surprised you or excited you the most in researching the way our brains work?
One of the biggest lessons I learned early on with doing the neuroimaging research I did was it's not just a single brain region that is going to be the answer to something like depression or anxiety. Okay. I got into this field with an interest in trying to alleviate the immense amount of suffering that is caused by depression and anxiety and different forms of that. And initially was very much interested in just doing the clinical work to just, help to utilize effective psychotherapies, which I still do to this day, to help people get to get better with depression and anxiety. Yeah. And then there was, then what was starting to show up with development with neuroimaging and these new tools for looking into the brain, that became a possible way to reach a lot more people if we could figure out what is going on in the brain with depression, anxiety. And in essence, we were looking for the brain region. That was my goal, was like, what brain region is doing this? Right. What's the problem? Right. And what can we target? And how do we go about targeting
what's
that?
Lighting up?
And what we found out, already 20 years ago, it became pretty clear. Things that were lighting up in the brain images that we were looking at was multiple brain regions. It wasn't just the amygdala. It wasn't just the insula. It wasn't just the prefrontal cortex, but it was...
Of course, it couldn't be that simple, right?
It's not that simple, right? And so that's one of the big lessons that I think, has been learned with regard to emotion, with regard to depression, anxiety, different forms of mental illness. And that's been, frankly, has been somewhat disappointing because it's been really hard to actually treat something that is more dispersed like
more
that.
Global like that. Yeah.
Right. And a similar kind of thing happened with, when the human genome got all mapped out.
Yes.
That was 20 plus years ago. And everybody said, oh, wow, now we're going to find the genes for depressions, for schizophrenia, for anxiety. And none of that has come to pass. And indeed, if anything, it is just like there are many, many genes that might confer a slight increased chance in getting these conditions. And that's important, but it's not straightforward.
Okay. Yeah.
So that's one of the main lessons that we learned in the research that I did, and I and many others did. Mm-hmm. One of the things that I'm most excited about now is actually in this whole area of neuroplasticity, which was not the research I did. It's at this more molecular level because of what it tells us about our brains and about the importance of thinking about what it is that we are spending our time doing. Mm-hmm. Because basically what we now know about the brain is that whatever it is that we're going to spend our time doing, our brains help us get really good at that through neuroplasticity.
Right.
So if we're going to spend a lot of time playing piano, and we do that maybe 2 hours a day, 4 hours a day, 6 hours a day, we get to the concert pianist, we can then play as a concert pianist. Mm-hmm. Same thing with sports. Right. Like the Olympic athlete, this is not just about training your body. Yeah. This is about training your brain, how to compete in that level. And your brain's directing the whole show anyway. Right. Right? Yeah. So the Olympic athletes, have utilized neuroplasticity to a tremendous degree to get themselves to the place where they can play or, perform at that level. Mm-hmm. But this also goes for, other areas of life. It goes for playing chess. It goes for video gaming. It goes for consuming news on, which is a big issue for a lot of people in this day and age with the divisive political climate we have. The more time that we are spending with that news each day, the more that's getting in and maybe affecting us, emotionally. Mm-hmm. And so with some of that too, this is why fake news works. Yeah. Why are we believing information that's incorrect? And people are then adamant that it's true. It has everything to do with repetition. Yeah, exactly. If you repeat whatever the information is over and over again, then you're going to build up neural connections for that, even if there isn't an ounce of truth in it. Yeah. And so quite frankly, I know talking about our current president is, people have different feelings about it, and there are people across this political spectrum, but he has been really a master of utilizing neuroplasticity. He puts out the information that he wants to put out there. He repeats it a lot. You'll hear it in his talks and speeches. He'll call somebody a liar or something not very positive, multiple times in a given thing. And then pretty soon we've got half of our populace that is walking around believing that that's the case.
Right.
So this is incredibly powerful what our brains are doing in terms of bringing in new knowledge and getting to a point where we can believe something very, very strongly.
Yeah, that puts a lot of responsibility on us to filter the true from the not true.
Yeah, there is that. And then there's also another side that I'm, obviously have focused a lot of my career on anxiety and depression. What's going on there with neuroplasticity? Well, for somebody who is, worries a lot, has a lot of anxiety, and has, over the years cultivated worry, they're really good worrier. I argue they've become the Olympic athletes, the Olympians of worry. Yeah. They're extremely good at it. And guess why? The exact same neuroplasticity mechanisms. Now, you might say, well, I haven't wanted to worry. The brain doesn't care that much. I mean, there's certain areas of the brain that care about whether you want to, but that's not how neuroplasticity works. Neuroplasticity is just like, whatever you're doing over and over, it's like, that must be important. I'm going to keep doing that.
Right. So if you're practicing something that's harming you, it's going to create neuroplasticity in that direction. Yeah.
Yep. And that goes for worry. It goes for the self-critical thoughts and thinking that occurs with depression.
Okay.
It even goes for suicidal thoughts. Yeah. The more that those are practiced, the more that kind of gets built up, and some of the ideas around suicidality get built up for a person. Self-harm types of behaviors, the more that is practiced, the more that gets built up. Eating disorder types of behaviors, problems with, restricting the amount of food you're bringing in, and the thought process of trying to control that gets further, just gets further and further entrenched in our brains through neuroplasticity. And so so it's really important for the treatment that we do is actually to start to move towards healthier thoughts and to move away from that.
Does that imply that anxiety and depression can be treated not just through medications, but actually through changing somebody's thinking and get the neuroplasticity, for lack of a better phrase, moving in a different direction?
Yeah, the idea would be to use neuroplasticity for something different than what it's been using. And absolutely, that is the foundation of cognitive behavior therapy.
That's exciting.
Is actually, we want to start to practice truths about the good things about a human being.
Yeah.
And that's our job as therapists and in our work with patients is to find what those truths about the positive aspects of who they are, what they are, and then to just repeat that over and over and over.
Okay.
And this is the kind of work that I do. I actually give people prescriptions, and I argue that my prescriptions are a lot more powerful than some of my psychiatrist colleagues' prescriptions are, which there is certainly a place for medication. Many of my patients are on medications. I work very closely with psychiatrists I respect a lot. But I give prescriptions as well. And my prescriptions are very simple statements that I'm asking people to repeat over and over. And I write it down on a little prescription pad and I hand it to them. And they're statements such as, for somebody who is, had a trauma history or has suffered sexual assault, it is not my fault. Is a lot of times they feel some self-blame there.
Right.
So that 4-phrase, it is not my fault, 5-word phrase is very, very powerful, and a lot of people don't believe, and they have to practice that over and over.
Yeah.
For somebody who's depressed, it is I am competent. I am good. Just a simple 7-letter phrase. I am good, and just and that has to be backed up. It's not just a positive fluff psychology. It's like we look at evidence from their own life. how they treat their people that they work with, what the types of things they do. They may be done well going to college. You identify the things that are good about these human beings,
Right.
and that's what you focus on, such that it is, the new statement, I am good or I am competent, it is based on evidence from their life. They may not be willing to look at that evidence, but us psychologists help, well, you did this, and you did this, and you did this, right?
Yeah, right.
And that's the foundation of it. And then that's got to be practiced a ton, because for some individuals that we see, they've been practicing since like 3, 4, 5 years of age, where they've maybe had a parent who says that they never did anything good enough, or that's not good enough, or you're an idiot, or stuff like that. And that's now been practiced. Like after you hear that a bunch of times, that just somebody else saying that to you builds the neural connection for you.
Right. And
then it's repeated.
Yeah.
They say it over and over again.
Yeah.
After a while, it gets internalized. What does that mean? We just start saying it ourselves. And then we're doing that for years and years in a host of different situations. So we got a lot of work to do in psychotherapy.
Yeah.
It requires a lot of repetition. Thankfully, it doesn't require the 40 years of repetition that they've been practicing the other one until they get to my office. But it requires, intensive repetition for a couple of years. And, you start to see changes already 3, 4, 5 months in.
That's exciting, because sometimes when I think about the power of positive thinking, or give yourself positive messages, it can sound a little woo-woo, but there's actual science behind this with neuroplasticity, and that is a great thing for people to know, because somebody even just listening to this podcast can just start giving him or herself positive messages and change the direction of this this neuroplasticity. Amazing stuff. I would love to ask you 100 more questions, but we should probably wrap this up before we get too long. But there are 2 quick things I want to ask. One is there anything about this, your research or your knowledge, that you would like to say, but I just haven't asked the right question to get to?
I think the big take-home message here is that it's really important how you are spending each and every one of your days.
Yeah.
And what you are spending your time doing and thinking about is being represented in your brain, and is building neural connections for that.
Yeah.
And to be aware of that, such that if you're practicing something that's unhealthy, that you're not feeling good about, find a way to stop practicing that and get to healthy behaviors. And if you're not able to do that on your own, go get the appropriate help, whether it's in, physical exercise domain, get in with a PT, physical therapist, or if it's, in the mental health domain, more specifically, go meet with a counselor or a therapist or a psychologist.
Okay. And the last thing I want to ask you is, just so we can get to know who you are a little bit outside of your professional life, do you have, other than giving yourself positive messages, do you have hobbies, sports? I'm pretty sure you're not boxing as a hobby.
So I've always loved sports of a variety of different types. But I think in terms of what's really important to me in my life, I have 3 children that are all in their 20s now, and they are. Being a father has always been a very important part of my life. It's part of why I'm here.
Yeah.
And then I'm also a martial artist. I've been a Taekwondo practitioner for almost 40 years, been an instructor for 35 years. So I'm an instructor here for a club on campus, and have done that since 1988.
Well, then I'm glad I managed to not get you angry at me, because you'd kick my butt.
Yeah, it's Taekwondo.
Taekwondo.
It's traditional training in Taekwondo, with a lot of focus on the mental aspects of the art, and some of the principles that guide that art when the art was designed. And they are integrity, perseverance, self-control, indomitable spirit, and perseverance.
Wow. Very much related to your research and your work. Mm-hmm. And now you're a full-time psychologist. Is that the correct term?
Yeah, so I'm a psychologist by training, and a neuroscientist. So and I am now, and I'm an associate professor in the Department of Psychiatry here in the medical school at UW. And most of my work now is just seeing patients. So I see patients in an outpatient setting. I do both group therapy and individual therapy.
Terrific. Dr. Jack Nitschke, thank you so much. I've learned a ton, and I wish we could do 4 more of these, because there's just so much about the brain that I want to know. But this has been very, very enlightening.
Thank you for having me.
You've been listening to the Badger Talks podcast. I hope you enjoyed my conversation with Dr. Jack Nitschke. Please browse our previous episodes for other topics that may be of interest to you. The Badger Talks podcast is a creation of UW Connects and produced at Audio for the Arts Recording Studio in Madison, Wisconsin. Our music is composed by Bill Purdy and performed by the UW Marching Band. I'm Buzz Kemper. Thank you for listening.